Hello students, this is the 13th part of functions. Today I am going to explain some problems. Most of the problems are based on finding domains. Okay, this is an important part for functions and finding domains. Listen, first one. First function given as 3 power x by x plus 1. Actually, this is a relation between x and y. What values of x, y should be a real number. That should find. That is called domain. So, whatever may be x is here. Whatever may be x, 3 power x is real number. But if you take x as a minus 1, denominator becomes 0. 3 power minus 1 by 0 is not a real number. That's why your x should not be equal to minus 1. Except minus 1, anything you can take instead of x. That's why I can say that the domain of the function is all real numbers except 1. Students, listen now. A function f of x is given as g of x by k of x. Y equal to g of x by k of x. To find domain of this function, find the domain of g of x separately, find the domain of k of separately, the intersectionally domain of original function. That is one thing. First of all, if some values of x, this function may be 0. For those values of x, y won't define. If this is 0, something by 0 is not a real number. First of all, you want to identify what values of x, this k of x function equals 0. Those values are not taken as the domain of the function. Okay. So here what happened here? See, 3 power x, no problem with 3 power x. In denominator x plus 1 is there. If denominator instead of x you write minus 1, then this fraction won't define. Except that the fraction will define. That's why, that is, if x equal to minus 1, then f of x is not defined. That is domain, anything you can take instead of x except minus 1. That is domain of f is all real numbers except minus 1. Okay, this is first problem. Second problem, f of x is given as 1 by x plus mod x. Okay. So first of all, we want to identify what values of x, x plus mod x is become 0, 1 by 0. That value should be subtracted from R. So first of all, I want to find what values of x, x plus mod x equal 0. First, find x so that x plus mod x equal to 0. Or another words, I can say that mod x equal to minus x. Now you want to use definition of modulus of function. Mod x equal to x when x greater than or equal to 0. Mod x equal to minus x when x less than 0. Mod x equal to minus x means what is the meaning of this? Your x should be less than 0. For these values of x, this is not defined. What do you want? Defined value you want? Means you want from all real numbers, you want to remove x less than 0 numbers. Less than 0 means negative numbers you want to remove. All positive numbers will satisfy. So 0 also won't satisfy here. So what I can say? Domain is equal to 0, open 0 to open infinity. Observe Nana. If x less than 0, this happens. X less than 0, this becomes 0. Take any negative number, minus 2 mod of minus plus 2, 0 only. No? X less than 0, this becomes 0. Even 0 also. So I will write that also, even 0 also. X lesser than or equal to 0. From all real numbers, you want to remove the values of x which are lesser than or equal to 0. Remaining values are domain. Remaining values means 0 to infinity only. Okay students, next simple problem, third one. F of x equal to mod of x minus, no fraction, nothing. Directly, instead of x, anything you can take, no, anything you can take. Minus 2, minus 3, no problem. X is, domain is all real numbers. Equal to all real numbers. Fourth one is interesting problem. f of x equal to root over 49 minus x square given. So again I want to explain, just like y equal to 49 minus x square. If this is a negative number, minus 2 for example, root over minus 2, not a real number, that means what is the meaning? This should not be negative. It may be 0 also, no problem. Root over 0, 0 only. Y is 0, real number only. So what is the meaning of that? That is 49 minus x square should be greater than or equal to 0. Such x values find, those x values only said to be the domain of the function. So to solve linear inequalities using wavy curve method, x square quotient or x quotient should be positive. That's why I want multiple minus on either side. X square minus 49 is lesser than or equal to 0, or x plus 7 into x minus 7 lesser than or equal to 0. Several times I repeatedly am saying, students, without concept of basic inequalities we can't solve problems in functions and remaining upcoming chapters. Please watch my videos again, basic inequalities by VGR. Okay, without that you can't solve these problems. So directly I want to solve this inequality. So first of all you want to take number line, minus 7, 7 plus minus plus minus 7 satisfies, 7 satisfies, and you want negative symbol. Negative means this area you want. Therefore directly I can write domain equal to all real numbers from minus 7 to 7 including minus 7 and 7. So this is the domain of the function. Okay. So here fifth problem. F of x is equal to root over a square minus x square. Same model. A square minus x square should be greater than or equal to 0. Or x square minus a square should be lesser than or equal to 0. Or x plus a into x minus a should be lesser than or equal to 0. Or x belongs to closed minus a to a, provided a is positive. Sixth one. This is also same model. Root over x minus alpha into x minus beta. So x minus alpha into x minus beta should be greater than or equal to 0. Now take number line. Now identify zeros. But here you don't know alpha is greater than beta or beta greater than alpha. But in bracket is given directly. Beta greater than alpha. Here beta, here alpha. So sign scheme applying plus minus plus. We want positive symbols. Alpha satisfies, beta satisfies. Therefore domain directly I can write. Domain equal to minus infinity to alpha closed union closed beta to infinity. Okay. So next seventh one, seventh problem. Yeah, what is that? F of x is equal to 1 by root over x square minus a square. So again root over, fourth root, sixth root, inside value should not be negatives. Means x square minus a square not negative, and not even though 0 also, because 1 by is there, no? 1 by 0 not a real number. That's why your x square minus a square should be only greater than 0. Here what happened? This is greater than or equal to 0. No problem. This is not in denominator. But here is the denominator. No? X square minus a is only greater than 0. How can you write x plus a into x minus a greater than 0? Take number line and complete the problem. Number line. Here minus a plus minus, minus plus, a won't satisfy, this also won't satisfy. We want positive symbols. So I want right here. Therefore domain x belongs to minus infinity to minus a open interval union a to infinity. Okay, eighth problem, interesting problem. Again, let f of x is given as eighth one. 1 by root over mod x minus x. So your mod x minus x should be greater than 0. Should be greater than 0. Mod x greater than x. Understood? No? Why greater than 0? Root over is there, no? And also it is not equal to 0 because it is denominator. Now you want to find the values of x which satisfy this condition. Generally you can say, no, if x should be a negative number. For example, you take x is a positive 2.3 for example. mod 2.3 greater than 2.3. 2.3 greater than 2.3 is wrong. Any number is not greater than itself. That means what happened? Positive real numbers won't satisfy this inequality. Take negative real number, for example, minus 2.3 is taken. Mod of minus 2.3 is greater than minus 2.3. So mod of minus 2.3 only, no? 2.3 greater than minus 2.3, correct only in statement. This is should be greater than negative number only. What the meaning of that? Negative numbers will satisfy. Negative numbers. What the meaning of? Therefore, I can say x belongs to, or x less than 0, I can say first of all. After that, domain, I can say domain equal to minus infinity to 0. But sometimes actually I want sometimes we need to explain in detail how to solve in detail. Mod x greater than x. How to solve in detail? To open modulus, mod x is then two cases will arise. X greater than or equal to 0 case, x less than 0 case. Okay, if x greater than or equal to 0, then what happened? Mod x becomes x greater than x, which is false. Means your x should not be 0 or greater than 0. That is final conclusion. If x is less than 0, so say this is first equation, this first becomes, if x less than 0, number 1 becomes what, Nana? Minus x greater than x. X less than 0, no? What is that? Do one thing, x less than 0, more clearly I will explain. X less than 0, take x is equal to some minus k, where k positive number. If k positive, then only with the positive with negative only negative, no? So what happened? 1 becomes actually, so minus x greater than x. Instead of x, what I can write? Minus k. Minus k I can write. Greater than minus k. K greater than minus k. True only, no? True statement. What is the meaning of that? Your x less than 0 values are satisfying. Therefore, x should be less than 0. X should be less than means what is the meaning of that? X belongs to open minus infinity to open 0. This is the domain. Okay. So directly I explained here and detailed I explained how to find domain. Okay. Yeah, students, next ninth problem. Yeah, ninth also interesting. F of x equal to root over 2 plus x plus root over 2 minus x by x. See the question, while observing the problem you can say that x should not be 0. If x equal 0, this fraction would define. That should take care. First one is x is not equal to 0. Second thing is 2 plus x should be greater than 0. Third thing is your 2 minus x should be greater than 0. Such common x you want to find. Okay, second one, what second one saying that your x should be greater than minus 2. What third one saying? Okay, what third one saying? X should be less than 2. No, combined I want to find number line minus 2 to somewhere 0. This should not be taken. What second? X less than 2. X greater than minus 1. Minus 2. So all these values except 0. Therefore, domain equal to minus 2. Open interval, but not included. No problem. R equal to 0 plus 0. No problem. R equal to closed minus 2 to open 0 union open 0 to closed 2. Or sometimes you can write like this also. Closed minus 2 to closed 2 minus at 0. Also correct answer. Okay, excellent problem. Excellent problem. Okay. The first step, first condition, step x whole square minus step x minus 2 should be greater than 0. To solve problems easily, I want to take step x as k. So k square minus k minus 2 should be greater than 0. Such k value I will find first, after that I will find x value. This is actually k minus 2 into k plus 1 greater than 0. Number line minus 1, 2 plus minus plus. What is saying that your k value should be less than minus 1. Sorry, less than minus 1, and your k value should be greater than 2. K means what? Step x. Step x should be less than minus 1. Step x should be greater than 2. Okay. Such values one find, after that their union only the solution of the problem. Okay. How to solve this? That is not at all easy. Observe all of you. So I think this portion no need, no, I explained clearly. Two things I got, I want to write those two things here. Mod x less than minus 1 or mod x is greater than 2. Okay. Yeah, take number line, students. First of all, I want to explain the concept. What value should take? So what is this? 1 minute. Yeah, less than minus 1. I wrote wrong here. Less than minus 1. Less than minus 1. Okay. Yeah. First of all, draw number line, students. What should, first of all, I want to complete this. What values of x, step x less than minus 1. Step this one. Step x less than minus 1. Less than minus 1. So instead of x, you write minus 9, minus 1 if you take. Step of minus 1, minus 1 less than minus 1, wrong, no? I will show you it. So this value can't take. If you take this value, minus 0 point something, minus 0.1 step is less than minus 1, minus 0.1 step minus 1 only, no? Minus 1 less than wrong only, means these values I can't take, these values I can't take. So if you take this value, what happened? Observe now. If you take this value, what happened? Observe. Minus 1 point something, step of minus 1 point something is less than minus 1. Step of 2 is less than minus 1. Correct only, no? Minus 1 is greater than minus 2 only, no? So what is the meaning of that? These all values you can take except minus 1. All these values you can take except minus 1. Okay. What I can say, that this gives x belongs to minus infinity to minus 1. Just now explain clearly. So what happened to this? I want to find. Again, what is this? 2. Okay. So take number line, here 1, here 2, here 3, here 0. Yeah, your step x should be greater than 2. Such x value on find. 2 you can't take, 2 you can't take. 2 minus also you can't take. 2 plus you take, 2.1. Step 2.1 greater than 2. Step 2.1, 2.2 only, 2 greater than, wrong. These values also won't satisfy. 3 satisfies. 3 plus satisfies. 3 satisfies, 3 plus satisfies. 2.1 satisfy, 2.1 satisfy. What is the meaning of that? Closer 3 to infinity. So x belongs to closer to 3 to infinity. Now I want to write final domain. Domain of f of x not correct. Rule on that one. You should write domain of f only, not f of x. F is minus infinity to minus 1 union closer to 3 to infinity. 7th problem. Interesting one this also. Step x minus x should be greater than or equal to 0. Such x value on form. What is actual x, nana? Step x plus fractional part of x. Okay. Or another words I can say that step x greater than or equal to x. Property, what property? Greatest integer function property, what property? Saying that your x always greater than or equal to step x. No? X should be greater than or step x only. This is one, but x should be greater than, or I will write it clearly. In this way I will, but step x always lesser than or equal to x. This is 2. A greater than or equal to b and a lesser than or equal to b. What is the meaning of this? A should be equal to b only. Then what happens? A greater than or equal to b and a lesser than or equal to b means what? A equal to b only. From 1 and 2 step x should be equal to x. What values of step x equal to x? Just x is integer. Only for integers, nana. Step x equal to x on integers. Okay. So x mustn't belongs to z. Therefore, domain equal to all integers. Interesting, important problem. Student, step x equal to, you take integer, other than integer, you take 2.1 for example. Step 2.1 equal to 2.1. Correct? Not correct, no. Step 2.1, 2 equal to 2.1, wrong. Understood? Means step x equal to x means x should be integer. Okay, this is 11th problem, Nana. Okay. Yeah, 12th problem, super problem, IMP model, this one also. First of all, cubed root of x minus 2 given, for example, just all real numbers I can take this one, all real numbers. Cubed root, no problem, cubed root negative also real number only. One thing, f of x is given 1 by cubed root of x minus 2 given. So, whatever be inside negative or positive, this real number only except one value. If x is taken as 2, this becomes 0, 1 by 0 not defined. For this function, except 2, all real numbers will satisfy. That's why here also 1 by cubed root of x minus 2 given. No? For define this portion, your x should not be 2. And after that some logarithms are involved, you need to solve that problem. Okay, don't apply logarithmic laws. No? Don't write this as log 4 minus x base 10. No, don't disturb the nature of the function. Don't disturb the given function. Without disturbing given function only you want to find this domain. Okay, first case is x is not equal to 2. Second case is 4 minus x greater than 0. Third case is base should not be equal to 1. No, 4 minus x is not equal to 1. Now I want to find common x which is satisfied by all these three conditions. Okay, what second condition saying that I will write. So x should be less than 4. What third condition saying that your x should not be equal to 3. So by using number line I want to complete the problem. Here 4. Okay, what this saying that your x should be less than 4. Okay. What is saying that x should not be equal to 2, at 2 open, at 3 also open. Except that all values you can take, What is the meaning of that? Yeah, x belongs to minus into minus 4. Minus 4 also open. From this, from 2 elements you want to subtract 2, 3. This is one of the way, or another way also you can write. So another way is x belongs to minus into 2 union 2 to 3 union 3 to 4. This is the domain of the function. Okay. Oh yeah, another interesting problem. Yeah. How can you write f of x equal to root over 4 minus x square by root step x plus 2? Conditions I wanted. First condition, 4 minus x square should be greater than or equal to 0. Second condition, step x plus 2 should be only greater than 0. Such common x you want to find. So first one I will solve first of all. X square minus 4 lesser than or equal to 0, or x plus 2 into x minus 2 lesser than or equal to 0. Use number line, minus 2 plus minus plus, this satisfies, negative symbols you want. Therefore x belongs to closed minus 2 to closed 2. This is the one solution. Next one is you need to solve step x plus 2 greater than 0. Step x plus 2 greater than 0, or step x should be greater than minus 2. So observe students, here 0, here minus 1, here minus 2, here minus 3, here 1, something is there. If you take instead of x 1, step 1 greater than minus 1 satisfies, 1 satisfies, 0 satisfies, all these values satisfies. What is minus 0.1? This one here 0 point minus minus 0 point something. Step of minus 0 point minus 1. Minus 1 greater than minus 2. Correct only, no? These values shall satisfy. Take minus 1. Minus 1 also satisfying. Take minus point something, minus 1 point something. Minus 2 greater than no, won't satisfy. Won't satisfy. What is the meaning of that? Minus 1 satisfy and all greater than minus 1 value will satisfy. Therefore, x belongs to closer minus 1 to infinity. Now I want to find intersection of these two. This and this intersection I want to find. So I want, I will find here, Nana. Observe here. So here minus 2 to minus 1. What this saying that your x value equal to minus 1 greater than minus 1. What is saying that your x value minus 2 and 2 included in between these two. The common area is this. Therefore, what I can say, x belongs to minus 1 to 2 closer. This is the domain of the problem. Okay. Next, this is also very important model, Nana. Logical question this one. Range f of x equal to sin pi into step x by 1 plus step x. In this problem, we want to find range, not domain, Nana. Actually, we want to find range, we should find domain first of all. After domain means input values or range of output values. No? First of all, you want to find input values, but this is special type of problem. You can say directly range. So listen, students, what is the value of sin 0? 0 only. What is the value of sin pi? 0 only. Sin 2 pi? 0 only. What do you mean? Sin n pi, where n is integer, what is sin n pi? 0 only. So here, what is step, Nana? Step x means integer only, no? Integer into pi, integral multiple of pi, numerator. Sin of integral multiple of pi, 0 only, always. That's why 0 by 1 plus something, 0 only. That's why whatever be x, your output always 0. That's why your range is only singleton set, that is set 0. Understood? I will write. Step x is an integer. Sin pi step x mean sin of integral multiple of pi. That is sin pi into x is always 0 for every x belongs to R. Okay. So what is the meaning? F of x equal 0 for every x belongs to R. F of x equal to 0 for every x belongs to R. Therefore, range equal to set 0. Okay, singleton set, constant function. Yeah, this is also interesting problem, Nana. 15th also interesting problem. Domain and range. Okay, domain. F of x by g of x form. First of all, try to identify what values of x. Denominator function is 0. Okay. So sometimes this may be 0. Always 0. What sometimes? Always 0 only this one, because integral multiple of pi. Always this is 0. This is 1. 1 plus 0. Plus if this is negative, sometimes, for example, this gives minus 1, then I can say for that value, denominator equal 0, but this value never negative, no, never negative, because x square step is given. X square only non-negative number. Step means least value 0. Other than that, greater than 0 only. That's why denominator is always positive. Means denominator never 0. Means domain is all real numbers. Denominator is a positive real. Real only, no? Okay, integer. That is better, positive integer, because 1 is integer, this is always 0, there is integer, no, positive integer. Therefore, domain of f is all real numbers. All real numbers. Numerator is different for all real numbers, denominator is different for all real numbers. The meaning of the domain is all real numbers. Domain completed. Now range. Same model. Your denominator never 0, Nana, is greater than 1 actually. Minimum value of the numerator 1, Nana. So again same argument, step means integer and pi integral multiple of tan of integral multiple always 0 only. Tan of pi into step x always 0 for every x belongs to R. What is the reason? This integral multiple of pi, no? Tan of integral multiple 0 only. So that is what the meaning of that, f of x equal to 0 for every x belongs to R. Therefore range set 0. Students, our next problem is logarithm is involved. Only one condition, single easy logarithm. No? What is the condition? Your x square minus 4x plus 3 should be greater than 0. That's all. So this is x minus 3 into x minus 1 greater than 0. Simple problem. 1, 3 plus minus plus open 1 open. Positive symbols you want. What I can say, x belongs to minus 3 to 1 union 3 to infinity. This is the domain. Okay. 17th. Yeah. Interesting one. 2 minus x greater than 0. First condition. Logarithm 1 by logarithm of 1 base 10. No? What is the value? Log 1 base 10 0. 1 by 0 not defined. That's why this 2 minus x also not equal to 1. That is another condition. Now you want to find x value which satisfies both the conditions. First one. So what first one saying that your x should be less than 2. What second condition saying that your x is not equal to 1. Then only 2 minus x 1 means x equal 1 only. No? So take number line. So what this saying that your x should be less than 2 and not equal to 1. Therefore domain equal to minus infinity to 1 union 1 to 2. Okay. Yeah. So this is very interesting problem. Logarithm is involved. Base is not mentioned. Assume the ternary. That is not big problem. X minus step x should be greater than 0. X should be greater than step x. Already you know the property, no? X greater than or equal to step. Always this happens. Okay, just now here you want to identify what values of x they happen. For example, you can't take integers. No, here you can't take integers. For example, 2 is taken, 2 greater than 2, not correct. No, we can't take integers. Other than that integer, anything you can take. For example, 2.1 is taken. 2.1 greater than step 2.1. 2.1 greater than step 2.1, 2 only. No, 2.1 greater than 2 only. That means what is the meaning of that? Any real number you can take instead of x except integers. Okay, understood? So for example, minus 3.4 is taken and is greater than step of minus 3.4. So minus 3.4 greater than minus 4, correct only, no? So anything you can take instead of x except integers. That's why I can say that domain is all real numbers except integers. Domain of f equal to all real numbers minus z. Yo, Babu, interesting problem. Okay. Condition 1. Logarithm of 3 minus x by x to the base 10 greater than 0. Condition number 2. 3 minus x by x should be greater than 0. First condition. What is the first condition? Logarithm of 3 minus x by x to the base 10 greater than log 1 base 10 I can say. Base is greater than 1, no, inequality won't alter. Directly I can say that 3 minus by x greater than 1 or 3 minus x by x minus 1 greater than 0 or 3 minus x by x greater than 0. Next page I will write, that is 3 minus 2x by x greater than 0. To use sign scheme, you don't want a negative symbol in front of variables. That's why multiplying minus on the other side. 2x minus 3 by x should be less than 0. Now number line here 0, 3 by 2. 3 by 2 means 1 point something here. 3 by 2. Okay. So plus, minus, plus, negative symbols I want. So x belongs to open 0 to open 3 by 2. This is the first part of the domain. Next part what? 3 minus x by x should be greater than 0. Yeah, I will write. Second part, 3 minus x by x should be greater than 0. Or x minus 3 by x should be less than 0. Number line 0, 3, plus, minus, plus. So negative symbols I want. X belongs to open 0 to 3. This is second part. Now I want to find their intersection. Here 0, 3 by 2, somewhere 3. 0 to 3. First this one saying that 0 to 3. What second one? 0 to 3 by 2. Intersection is this one only, no? Therefore domain equal to open 0 to open 3 by 2. Okay, so I made a mistake here actually. This equal 0 also no problem, no? That's for first condition r equal to 0 here. First condition. Yeah, first condition, for not second, first condition. So what happened? 0 won't be in denominator, that's why 3 by 2. 3 by 2 satisfied. Here, this is okay, this is everything okay. Here, close the 3 by 2, that's all. Yeah, next problem. This is also interesting. Condition number 1. Logarithm of x minus x square to the base 0.3 should be greater than or equal to 0. Condition number 2. Your x minus x square should be greater than 0. Now I want to find common x which satisfies this condition. Okay, first one. Logarithm of x minus x square to the base 0.3 greater than or equal to logarithm of 1 by 0.3. Inequality will alter, no? Because 0.3 is base. X minus x square lesser than or equal to 1. Or x square minus x plus 1 is greater than or equal to 0. Okay, students. Now next I want to write here. I think this is always greater than or equal to 0. All real numbers will satisfy this. Already you know that x square minus x plus 1 minimum value 3 by 4. 3 by 4 to infinity this. Okay. Or try to make it into perfect square, nana. 2 into x into 1 by 2 plus 1 by 4 minus 1 by 4 plus 1 greater than or equal to 0. X minus 1 by 2 whole square. Yeah. Plus 3 by 4 greater than or equal to 0. So for every x it happens, no? So x belongs to R, I can say. This x belongs to R. This is the first part. Second part I want to find. X minus x square greater than 0. X minus x square. X minus x square greater than 0. X square means x less than 0. X of x minus 1 less than 0. Number line 0, 1, plus, minus, plus. So negative symbols I want. X belongs to open 0 to open second part. Now I want to combine first part and second part. 0, 1, open 0, open 1. What is all real numbers? All real numbers. So this is common for both. That is all real numbers is 0 to 1. Therefore I can say that x belongs to open 0 to open 1. This is the domain of the function.